as you're working through the homework, you will see that some of the problems say solve this system using substitution. And some of the problems say solve this system using addition. And some problems say solve this system using any method. Okay? Make sure you're following the directions because I reserve the right to use any of those directions on exams and quizzes. I might want to see that you know how to do each particular method, so I could specifically say on this problem I am testing you on substitution, and on this one I'm testing you on addition. There are also some, though, where it says use any method, and I might do that as well. That means you get to choose. In some ways that's kind of nice, because if the method that you prefer works well for that problem, you can use the method that you prefer, but you do have the added task of sort of analyzing what's the best method. So question 34 is in the section where it says to solve by any method. Okay. What I want you to do is just take a moment and think about which method you would prefer to use for this particular problem and why. Don't actually solve it. Just figure out which method you think is going to work better for this particular problem. There isn't necessarily a right or wrong answer, but I want you to think about that and strategize for a moment, and then tune back in and we'll talk about strategy, and then we'll pause again and solve it. Just thinking in terms of strategy, I think this is kind of an interesting one. You'll notice that the types of terms in the two equations don't completely match. This has x squareds and y squareds and numbers. This has just plain old x's and y squareds and numbers. So I couldn't use elimination to get rid of the x's, although I could use the addition method or the elimination method to get rid of the y squareds. And if I did that, I would end up with some x squareds and some x's, so I'd have a quadratic in x. So that could work. But you might have noticed that we've already actually solved for x. If you've already solved for one variable, that's your first step in substitution. That's already done for you. So that might make substitution look kind of good. Okay. If I do that, I'm plugging this whole thing in for x, so I'd be squaring that. Okay. So that's going to give me some y to the fourth. That's going to raise things up to some slightly bigger powers. So I can sort of see some pros and cons to both methods. I don't feel like there's a right answer, like this problem must be done one way or the other, but I hope you had a chance to think about what you see that would work and what you think would be simpler for you. I'm actually going to go ahead and solve this both ways. What I'd like you to do is take a moment, pause the video, solve the problem at least once. Pick at least your favorite method for this particular problem, the one that you think is going to be simpler, and solve this system. If you're feeling ambitious, try it both ways. When you tune back in, we'll go over it both ways. As I said, I don't feel like there's necessarily a right way to do this problem. Either method is going to work. We're going to work it out both ways. I've arbitrarily chosen that I'm going to do the substitution method first. Okay, so we've already solved this for x, so I'm just going to plug that in for x in the other equation. So on the top of that fraction, I've got the quantity, negative 2y squared plus 2 squared. That's all over 4. And then plus y squared equals 1. Now remember, when we square this, we're multiplying together two factors of negative 2y squared plus 2. So we're going to have to FOIL that out. So when I do that, my first terms will give me 4y to the fourth. I'm squaring y squareds, so I'm getting the fourth power. Outsides give me negative 4y squared. Insides give me a negative 4y, another negative 4y squared. So that's a total of negative 8y squared. Last terms give me plus 4, and all of that was over 4. Plus y squared equals 1. Now it's kind of nice that each of these coefficients here is a multiple of 4. I'm just going to distribute that division. So I've got 4y to the fourth over 4, minus 8y squared over 4 plus 4 over 4 plus y squared equals 1. And all of these 4's are going to cancel now. So it's y to the 4th minus 2y squared plus 1 plus y squared equals 1. Let's combine those like terms, those y squareds. So y to the 4th minus y squared plus 1 equals 1. I'm going to subtract that 1 over. So we've just got y to the 4th minus y squared is equal to 0. So we've got some higher powers of y, but we can still factor this very nicely. Y squared factors out, and then I'm just left with y squared minus 1. Whoops, y squared, not 2 squared. Y squared minus 1 equals 0. Okay. And of course that factors even further. That's y plus 1, y minus 1. Okay. Now, if you wanted to solve y squared minus 1 equals 0, keeping that together, that's totally fine. But we should actually get now 3 answers for y, because we're either going to have y squared equals 0, or y plus 1 equals 0, or y minus 1 equals 0. Now, if y squared equals 0, that means that y is equal to 0. This would mean y is negative 1, and this would mean y is positive 1. Okay. So we've got 3 y values that work. Now for each of those, we've got to find our x value, and I think the easiest way to do that is to plug into the equation that's already solved for x. Okay. So if y is equal to 0, if x is negative 2y squared plus 2, that would be negative 2 times 0 squared plus 2. That's just going to be 2. Okay. So I'm going to have the point 2, 0. Now if y is 1, then x is negative 2 times 1 squared plus 2. 1 squared is 1, times negative 2 is negative 2 plus 2. That's going to give me 0. So I'm going to have the point where x is 0 and y is 1. And let's just try if y is negative 1. X is negative 2 times negative 1 squared plus 2. Well, that's going to give me the same thing, because negative 1 squared is still just 1, so I'm getting negative 2 plus 2, I'm getting 0. So we'll also have the point 0, comma, negative 1. All right, I'm going to put just up in this right-hand corner here that my 3 solutions were 2, 0, 0, 1, and 0, negative 1. We said that this one could be done using elimination or addition. Can use those words interchangeably, using the other method, which our book calls addition, instead. So this was x squared over 4 plus y squared equals 1. I'm going to just move those y squareds over to the other side. Okay, so I'm going to add those over. So it would be x plus 2y squared is equal to 2. Now here and here I've lined up like terms. These guys actually aren't like terms. I think just so I don't make a careless mistake, I'm actually going to slide the x's over. So these are x's, these are x squareds. They're not going to cancel out and they're not going to combine because they're not like terms even though they involve the same variable. So the only thing I'll be able to eliminate is the y squareds. Looks like I want to multiply that first one by a negative 2. Okay. So if I multiply that by a negative 2, okay, I'm going to have negative 2x squared over 4 minus 2y squared equals negative 2. Now I can see this first fraction here would reduce. That's just going to reduce to negative x squared over 2. Okay. Let's keep this second equation the same. X plus 2y squared equals 2. And now I can add the two sides. The x's don't cancel out. The x squareds don't cancel out. The y squareds do. And negative 2 plus 2 is equal to 0. Okay. So I've gotten to this equation, I'm going to just rearrange it to write it in descending order. Negative x squared over 2 plus x is equal to 0. Okay. And if I want to, and I think I do, I'm going to just multiply both sides through by 2 to eliminate that fraction. Okay. So if I were to multiply through by 2, I'm going to get negative x squared plus 2x is equal to 0. And now I can factor. Let's factor out an x. Okay. Often when I'm factoring, I prefer to have my squared term negative. This one's nice enough because I can just factor out a greatest common factor and I'm not unfoiling, that I'm okay keeping that negative. Some of you might have chosen to multiply through by a negative 2 to make the x squared term positive. That would be totally fine. Here, what I'm going to have is x times a negative x plus 2 is going to equal 0. Okay. So either x is equal to 0 or negative x plus 2 is equal to 0, which would mean x is equal to 2. You'll notice that's consistent with what we got. The x values for our solutions were either 0 or 2. Let's confirm that we get the same y values. Okay. So if x is equal to 0, but x was negative 2y squared plus 2, that's going to mean that 0 is equal to negative 2y squared plus 2. 2y squared would equal 2. Y squared would equal 1. Now I could move that over and say y squared minus 1 is 0 and factor it, or I could say y is plus or minus 1. So there are those points, 0, 1, 0, negative 1. If x is 2, we get 2 is equal to negative 2y squared plus 2. If I subtract that 2, I get 0 is equal to negative 2y squared. Y squared is equal to 0. Y is equal to 0. So either method, I actually get the same solutions. And it's kind of neat sometimes when both methods work to try it both ways and see which you prefer. Some of you might have said, I really didn't like having y to the 4th. I don't like getting those higher powers. I'd prefer to avoid that if I can. Others of you might have said it felt a little weird to use elimination when I didn't have all the same types of terms. Totally up to you in this particular problem. Hope you understand both ways of doing it and have some sense of how you're going to strategize about which method to use for particular problems.